All right, so we're going to continue talking about exponents. Today we're going to divide exponents with the same base. Now, the rule to divide exponents is going to be very similar to that of multiplying exponents. Now, we're going to have a problem to start, right? So we're going to think about what is 6 to the 6th power divided by 6 to the 4th power. All right, so 6 to the 6th power is going to get you this big number, and then 6 to the 4th power is going to get you this big number here. All right, so you could evaluate that and do 6 times itself 6 times, 6 times itself 4 times, and then divide, right? You might need to do long division or whatnot, but hopefully you can see that that's a super tedious process, right? And in the next slide, there's really an easier way to do it that relates to the topic of exponents that we've done before. Now, what you could do instead is we can expand the numerator and the denominator, right? So 6 to the 6th power, I know that that's 6 times itself 6 times, right? 1, 2, 3, 4, 5, 6. And I know 6 to the 4th power is times itself 4 times, right? 1, 2, 3, 4. Now, if you divide, what happens is you can cancel out common factors on the top and on the bottom, right? So on the top, I can cancel out as many 6's that match, and you're left with 2 6's left over, right? So 6 times 6, which is 36. Right, and as you can see, that's much simpler than if you were to fully expand, fully evaluate each of these expressions and then divide, right? It gets you something a lot simpler. Now, what really happened here is subtracting the exponents, right? So 6 to the 6th power divided by 6 to the 4th power, you can just subtract the exponents, and that gets you 6 to the 2nd power, which is 6 times 6, which is 36. All right, so it relates just like what we did in multiplication, right? So when in multiplication, we added the exponents. In division, we subtract, right? So this is just another rule that we can use that's going to help us simplify some expressions. All right, now we can do the exact same thing with variables, right? It doesn't have to be a number. As long as the variable is the same on the top and on the bottom, then you can use this property. Right, so you can expand, for example, x to the 5th and x to the 3rd, and then cancel out the common factors, right, and you'd be left with 2 x's, right, so we get an x squared here. Or you can just subtract the exponents, right, you need to write it out every single time, but you do have to know is that the exponent on top goes first, and then the exponent on the bottom goes second, so you get x to the 5 minus 3, which also gets you x to the 2nd power. All right, so let's do some let's simplify some expressions. This first one, 7 to the 5th over 7 to the 2nd. Right, a couple ways you could do it. You could just use the fact that if we expand, right, if we expand 7 5 times and we expand 7 2 times, right, we get common factors on the top and on the bottom, and you're just left with 3 7's, right? So that's 7 times 7 times 7. 7 times 7 is 49, and then times 7 again. You guys can verify and work this out. This is going to get you 343. All right, but you don't want to do that every single time, right? What you do want to do instead is use our exponent rules and say that this is 7 to the 5th minus 2, and then 7 minus 2 is 7 to the 3rd, which is also 243. Right, so we should get the same answer. 343. All right, so we should get the same answer, but this is the way to go, right? It's good to understand that this is why we do it, but you don't want to do that every single time, right? So let's keep going. 3 to the 9th over 3 to the 2nd, right? The 3's are the same, so if the 3's are the same, you're going to keep that as your base and then subtract your exponents, right? So we get 9 minus 2, which is 7, so we get 3 to the 7th. All right, now this is something that I wouldn't want you guys to evaluate. All right, 7's a pretty big exponent to have and to multiply that many times, right? I don't want to do that. So what you can do is you can just leave it alone. All right, so again, I'll tell you guys, and you guys are going to know come test day what to do exactly. But yeah, so in general, typically anything over 4 in the exponent, we just leave alone. Right? We don't really evaluate that. So 5 to the 2nd over 5, right? You could use your rules of exponents, right? If you don't see an exponent, you assume it's 1. So we get 5 to the 2 minus 1, which is 5 to the first, right? And then 5 to the first is just 5. Right, but also 5 to the second, that's a pretty small number compared to some other ones that we get. Right, 5 to the second power is 25, and then 5 to the first is just 5, and then 25 divided by 5 is 5. So you don't always have to use the rules of exponents, right? I mean, 5 to the second is a relatively small number, so we don't really need to do anything special with that one. We can just evaluate that one like normal. But if you did use the rule, it would work, right? We can see that it works every time. All right, so now this next one, 4 to the z over 4 to the fourth, right? Z is a variable, but we don't really have any more information, right? So 4 is the same on the top and on the bottom, so this is going to become 4 to the z minus 4. And that's all you can really do there, right? Z isn't a number, so you can't really combine it any further, right? You can just leave it alone like this. All right, so now this next one, I have m to the 3/4 over m to the 1/2, right? So if you have rational exponents, you can do the same thing, right? I have a base of m on the top and on the bottom, and that's going to be my base, and the exponent on top is 3/4. The exponent on the bottom is 1/2. So I could do 3/4 minus 1/2. Now, from this point, you guys should know how to simplify how to simplify fractions, right? Or add and subtract fractions. They have a different denominator, so I want to multiply the top and the bottom by something that's going to get us the same denominator, right? And if you multiply the bottom by 2, then you get that 2 times 2 is 4, which is something that we know what that is, right? So this is going to become m to the 3/4 minus 2/4, which is m to the 1/4. All right, so that's all we need to do with that one, right? That's as far as we can go. All right, and then this next one, p to the 6 over p to the 5th, right? They have the same base of p, and they have exponents. So what I can do is I can subtract the exponents. This is going to become p to the 6 minus 5, and that's going to become p to the first, right? And you don't have to write it if it's to the first power. You can just write p, right? That's perfectly acceptable. All right, and now this next one, r to the 3rd over r. If you don't see an exponent, assume it's 1. So this is going to become r to the 3rd minus 1, which is r to the 2nd power. All right, and now this next one, I have multiple variables here, but just like with multiplication, you just want to do whatever variables match, right? So x is going to match with x, y is going to match with y. Right, so that's what I'm going to do in this problem, right? I'm going to do x to the 5th divided by x to the 3rd, and that's going to become x to the 5 minus 3. All right, and then I'm going to do y to the 4th minus y to the 1st. Once again, you don't see an exponent, assume it's 1. All right, and then simplifying those, this is going to get me x to the 2nd, y to the 3rd. All right, so slightly different examples here, but not entirely difficult, right? So here I have a to the 3rd over a to the 5th. I'm still going to use my same property of exponents, and I'm going to do a to the 3 minus 5. But when you do 3 minus 5, you get a negative answer. So you get a to the negative 2. All right, now anytime you have a negative exponent, hopefully you guys know by now, you need to move it to the bottom. So this is going to become 1 over a to the 2nd power. All right. Now, when it comes to something like this, I'll actually show you what it looks like when you fully expand it. So I get a times a times a, and then a times a times a times a times a. Right, now, if you do the same thing that we did before and we cancel things out, notice you're still left with 2 a's, but on the bottom. Right, so that's another way that you can think of this problem, is that you have 2 a's on the bottom, so that's going to get you this a squared. And then on the top, a lot of people are tempted, if you do it this way, to put 0 because there's nothing left. You would really put 1, right? You want a factor of 1 on the top. All right, so that's another way to do the same problem, right? If you know your properties of negative exponents, though, and it shouldn't be super difficult to just subtract and then simplify from there. All right, now let's do the same thing, or no, let's do what we've been doing, right, on number 10. right? So here I actually have numbers in front of my variable, right? So now my 10 and my 15, I can just treat those like regular numbers, right? If I ignore the variable, 10 and 15 share a factor of 5. So what I can do is I can divide the top and the bottom by 5, and that's going to get me 2 over 3, right? 10 divided by 5 is 2, 15 divided by 5 is 3. And then I can still do the same thing with my exponents, right? Keep in mind my x as my exponent, my x as my base is going to go on top to begin with. And then from there, if you have a negative exponent, you can move it to the bottom, right? But I'm just going to leave it on top and then see what happens when we subtract our exponents, right? We get 5 minus 2, which is 3. So our final answer is 2x to the third over 3. All right. Now, just to emphasize what I was just talking about, if let's say I had a negative exponent here, like let's say that was a negative 3, then from there you can move this to the bottom, right? But because it was just a normal positive exponent, then you can just leave it alone, right? But that's on a case-by-case basis, right? So anytime you do your power to a power, you just want to make sure that you're left with something that makes sense and something that's fully simplified. All right, now that completes all of the exponent rules. We're going to do more practice in class in preparation for your test.